And usually complex numbers are visualized as a plane. Complex number plane. We have a real number line. We have what we think of as an imaginary number line. But the complex numbers, numbers that look like this, are a combination of the reals and the imaginaries, the complex numbers. Okay? So we could think about, plotting that point. That would be a real hard thing to do. 2 plus 3i. Here's 2 in the real direction, here's 3 in the imaginary direction. So that point there we could think about as 2 plus 3i in a similar way to the way we think that this point right here is just the number 2. You know what I'm saying? We can kind of think about that correspondence. We can think about real numbers or complex numbers as points on a plane. So let's see if all the other stuff that we can do with regular numbers, we can do with real numbers. For example, I know how to do this with regular numbers. I should be able to figure out how to do this with complex numbers. I should be able to take 2 complex numbers and add them together. Anyone got any bright ideas how to do it?
Just basically
Absolutely, yeah. 2 plus 3i, 1 plus i. He says basic addition, so it's going to be, wait, 5, 6, 7.
Well, no, those are.
We got to think about like terms, don't we? Yeah, okay, so 3 plus 4i. That makes sense. That makes sense to me. Let's see, let's look at that. First of all, I'm going to graph 1 plus I in black. And I didn't do a very wonderful job of picking these things out, but there we go. And now I will graph 3 plus 4i. I'll graph the sum of those things. So the sum would be here and here. Okay. I'm about to erase this because I have better numbers that I want to graph. But I forgot my rag. Can I get a napkin, John?
Yeah.
Just a napkin. Is there any napkins over there? You don't have to go running around. If not, I can do this.
No napkins.
No napkins? We expect you guys to eat cookies without napkins? Yeah. Well, that's called being on a budget. All right, so let's look at this. I'm going to look at another one. And I'm going to just have you guys try this. That's good. Thanks, John.
Sure.
I'll let you guys do this first, and then we'll come up and we'll graph them. So I'll let you guys real quickly. Negative 3 plus I. So I don't think this is going to take forever to do. And you got I hope most people came up with something that looks like that. Does that make sense? Okay. People are not even trying because it's so basic. That's good. Let's look at how these things look. Let's look at how these things look on a piece of graph paper. So I'm going to take negative 3 plus I and 3 minus 4i. So negative 3 plus I is going to look like this. And positive 3 plus 4i is going to look like this. 1, 2, 3, 4. And then 0. Excuse me. Positive 3 minus 4i will look like this. And then 0 plus 3i is going to look like this. Now, I'm going to start thinking about these in terms of what we call later vectors. I'm going to think about each of these complex numbers in terms of vectors. If we do that, we can put negative 3 plus I. We can think of negative 3 plus I as a vector that goes out to this point. It's very similar to thinking about the number 2 as a positive arrow that goes there, and then if I want to add 2 plus negative 3, I can put 2 this way, and then I can go negative 3 this way, and I can end up at negative 1. We can think about these complex numbers in similar ways. I'll think about the first one, and I'll erase this in just a second with a right. You can think about the first one like this, the second one like this. Oopsie. And if I put, similar to the way that I put negative 3 and positive 2 back to back, or head to tail here, if I put these two head to tail, if I take this one and move it right down here, I end up at the same place that I would have when I originally did my math. Does that make sense? Oh, Josh, it does. Nice. I end up at the same place I would have when I originally did my algebra. So we can think about adding complex numbers as putting these arrows, these vector arrows that illustrate the complex numbers head to tail. We're going to have to do this later, because what I want to do later is talk about how to generate a set of complex numbers called the Mandelbrot set. And part of generating these numbers entails being able to add them. So, but in general, first things first, I'm going to write that up here. Adding complex numbers is just like placing them nose to tail. Is that a good way to write what I just said?
Yeah.
Okay. So we got a way to add complex numbers. Originally, I was going to have you do it, but I won't have you do that one. But I will have you guys try to figure out what goes on when we multiply complex numbers. So the next thing I want to show you is this one. Here's a couple of complex numbers. Turns out that something pretty interesting, I think, happens when you take two complex numbers and multiply them together. I'll let you talk about how you think you might think about how to multiply them together at your desks. So try to figure out at your table, how would you multiply those things together?